Now, as promised, I'm going to show an example where we will see that the heat and the work that are entering or exiting the system are dependent on the process, not necessarily on the endpoints of the PV diagram. Now here we have a cylinder filled with gas, and in the first two cases, as we can see here, in the first two cases the cylinder is actually isolated except on the bottom, and on the bottom is in contact with a heat reservoir. Now a reservoir is basically a large energy source where even if the reservoir absorbs or emits energy, there won't be necessarily a temperature change in it. So basically we're using the reservoir in order to make the temperature constant in our system. Now first of all, let's say that we're holding this piston with our hand, and since we want a quasi-static process in order for each point to be mapped on our PV diagram, since remember, a quasi-static process means a process that runs slowly and at every point is in equilibrium, internal equilibrium. Now as the force that we're exerting on this piston is lessened, this piston will rise, and as we can see here, the volume will change. So basically we have that the temperature stays the same, so T initial is equal to T final, and also while the volume increases, so from V initial we go to V final. Also take note of the pressure, that it also changes. Now in the second case we also have a cylinder, but here instead of having a heat reservoir, we're going to isolate the system from all sides. And also this is the second case. We can imagine that first of all, this system, there has been some membrane, let's say, that has prevented the gas from expanding into the whole cylinder, and then when that membrane is, let's say, popped or removed, then the gas will expand through this whole volume. So again, the volume initially in this case was the same as here, and then expands to some V final, which is, I didn't go to this one. But take note here, actually here, neither, since the system is isolated, there is no heat either flowing in or out of the system. Also, since you were not exerting any force on this cylinder here, actually there is no work done by the system. So basically, the difference between two systems, as we can see, even though the initial and final points are identical, we can see that in the first case we have a certain amount of heat flowing into the system and also some certain amount of work being done by the system, while in the second system the work and also the heat are equal to 0. And that is all for this video. In the next video we're going to study about the first law of thermodynamics, and then we're going to continue on with some applications of the first law.